Hi everybody, we're back again. We're talking about Tricks of the Game Programming Gurus, this book written by Andre Lamoth back in 1994 when I got this book. And we are still on chapter 2 talking about assembly language basics. So last week we just talked about getting things set up using Visual Studio Code to edit your code and then to compile it. We talked about linking to a compiler, Digital Mars compiler, which allows us to compile into 16-bit instructions, which will allow us to then run it in DOSBox. When I left off, we just very quickly put this program together, which will change the video mode and then into graphics mode and then switch it back into text mode. But I didn't really talk about anything on what this code is actually doing. So let's just run through that real quick. First you'll see that in our main function here we're just setting the mode, waiting for some keyboard input, and then setting it back to text mode. And these are just some constants that are defined up here. This is hexadecimal, so it's mode 13H and mode 03H. And what you'll see is just these 3 assembly instructions here. The first one is move AH 0, and that means this is the high order byte, so the A register is a 16-bit register, and you have a high order byte, which is 8 bits, and a low order byte, which is another 8 bits. And so we're just setting the high order byte to 0, and then the low order byte we're setting to this variable that we passed in the function. So the first time we're setting it to this 13H. And then we just call this interrupt, which is this 10H interrupt, which is actually a BIOS call. It's a BIOS interrupt here. And you can look this up on Wikipedia. I just quickly looked up this information. But this gives you the just the rundown of what this interrupt call actually does. And you can do a lot of different things with it, but you can see what we did here is we are wanting to set the video mode. So what you need to do is set the high order byte to 0, and then the low order byte you want to set to the video mode that you're requesting. So what we do in our code, we set the high order byte, set the low order byte, then run the interrupt, which will set the video mode. Then we wait for the keyboard command, or wait for the user to press a key, and then we set it back into text mode. And again, I just did a quick Google search to look at all these different modes. These are the modes that are available to VGA compatible boards, and the one we're changing it into is this 13H, which you'll see is this 320 by 200 resolution with 256 colors, and it's a graphics mode. And when we set it back, we're setting it to 03, which is a 16 color mode, and it's a text mode with 80 characters by 25 characters. So when you go into this, you'll see this is 80 characters horizontal and 25 characters vertical. So that's a rundown, very simple rundown of what this set mode function does. And let's just compile this again. You'll see everything runs or compiles correctly, and then we'll go into here and run this, and works great. So moving on, today we just wanted to talk about there were 2 examples in this code on the CD. On the CD for this book, this CD right here, is everything's in the source folder, And chapter 1 is just an introductory chapter, so there's no source code, but chapter 2 is the code that we got. And this is the one that we worked on last time. But today we want to look at this other code, which is fill. It's a fill example. So I'm going to drag those over here into my editor and have a look. So we have this fill.c and fill.assembly file, and let's just run through this real quick again, what this program will do. You see our main method here. We're just setting the mode to VGA like we did last time, and when we exit we're setting it back into text mode. The interesting part is the in between here. We're going to be cycling through a for loop between 0 and 1000 and filling the screen with this T, which is a color. So this fill screen is an assembly function. So if you look at the assembly here, this part right here is the relevant stuff. This other stuff here is just kind of some overhead that we're not actually going to be using since we're using the inline assembler. We don't need either of those parts, but here's the relevant code here. What we're going to be doing, we'll go ahead and copy this code over to our program and work on our own example. So I'm gonna go back over to my test program, and we're just gonna get this set up. So I'm just gonna copy the relevant pieces of code here. And here's the assembly, so I'm going to create a new method here, a new function called fill screen. Oops. And then we're going to use the inline assembler again. And we have to change out these comments to this style of comments since we're using the inline assembler instead of some sort of assembly compiler. We need to change this out with a variable here, which we're going to add this variable color here. The other thing that's missing is this screen RAM, which you'll see that we have defined as a constant up here. So let's just define that as a constant up here. We're going to try this. And let's just give this a, let's see if this compiles first. It says undefined label screen RAM. Let's try and plug it in like that. Okay, and then it's saying this T is an undefined identifier. So we are missing this up here. We have to define the variable. And then this actually links and compiles. So let's go ahead and run this, see what happens. And as you can see, we are using our assembly call to write colors to the screen. So that works. For the remainder of this video, let's just step through this assembly function to see exactly what it does. And big disclaimer here, I'm by no means a an assembly expert. I just have a very basic understanding of the concepts. So bear with me, and if I say something wrong, feel free to correct me in the comments. But we're just going to run through this real quickly. What we're doing in this fill screen method is the first instruction, we're just setting there's different registers. This is the accumulator register, which is, from my understanding, just a pretty general use register. Then we take this value and we ultimately want it in this ES register, which stands for extra segment register, which we'll be using this in the code down below. And this XOR function right here, what this actually does is essentially doing this. So we're just setting the D register, which stands for destination index register, to 0. But this is kind of an optimized way of doing it. It takes the same amount of cycles, but it's, I think, 1 byte shorter. That's my understanding of it anyway, so it's an optimization of sorts. But anyway, we're just setting it the DI the destination index register to 0. Then here we are setting this counter register to this value. And basically what we're wanting to do is go through every pixel on the screen, and there's going to be 320 by 200 pixels, which that would be 320 by 200 pixels is 64,000 pixels. But we're going to deal with everything in 16-bit chunks, which is called a word. So a byte is 8 bits and a word is 16 bits. So we're going to be dealing with words in this. So we're just going to divide that by 2. So this is going to be 32,000. We're basically setting this counter index to 32,000. And then we're going to set this, the A register, the low order bit, to whatever color was sent in here. So let's just say the color is 0. So we'll set the color here to 0, and then we're also going to move that same color up into the high register. And this is just an optimization. Rather than working byte by byte, we're going to be working word by word. So that's just 16 bits at a time. And then this is the magical command right here that just blasts the video RAM. So essentially, I think I forgot to talk about here what this screen RAM is. This offset is where the video memory actually starts. So we're setting the the ES register to the beginning offset of where video memory starts. And this okay, so this is the magic command here that's going to do all this stuff for us. But this STOSW, what this command does is, and I just had to look this stuff up, but what this command does is it takes the value that is in the A register, which we filled in with the color and the color. So we have 2 bytes each with the same color, and it copies that into the location of this ES register plus the DI, which is basically the offset. So ES is the base and DI is the offset. So when you first start, DI is 0, but this command, each time it's called, it will increment DI. So it'll be DI plus plus. It will actually it's DI plus equals 2, because it will go 2 more bytes each time this operation is called. So that causes this to go over and over until the entire screen is filled up with whatever color you sent in to the call. And then this repeat action, it just causes this thing to go over and over again, and this repeat operation will decrement this C counter until it equals 0, and then when this tests for 0, it will stop this function. So it's just going to go over and over and over 32,000 times until it stops. So it's 32,000 words in an entire screen. And that is basically what's happening there. Now, one thing that bugged me about this program a little bit is you'll see that we're actually passing in an int, which is a little strange because we are in 256 color mode, which means 1 byte represents 1 pixel, which means we have a maximum of 255 colors, between 0 and 255. So I'm going to go ahead and update this function a little bit. I think what the author was getting at here was he just wanted this demo to last just slightly longer. So he's going 1 through 1,000, but once it reaches 255, it goes back through 0 and 255. So this kind of happens like 4 times, but we're just going to change this to 255, and I'm going to change this to an unsigned char, which is basically a byte, which will allow us to go between 0 and 255. And then I will use this same up here. This is an unsigned char. And then let's compile this again. It compiles, and let's run it. And it's shorter, but it's just more accurate in my opinion. We're just going through the entire 256 color palette one time. So the final thing I wanted to do in this is I just wanted to put a get here so that we can cycle through each. Oops, sorry, I need to compile first, just so we can get a better idea of what's happening on each color. Okay, so let's run this program one more time, and you can see this is the first color, or color 0, and color 0 is black, and then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you can see color 15 is white. So the first 16 colors are just this is just the default palette that your VGA card will have loaded by default. That's what I'm assuming anyway. And then after you get past the first 16 colors, the next one you'll see is another black, but then there's this gradual gradient from black to white, and then it goes on to some other colors which I'm not sure how they're organized, but this is the basic VGA palette that's going to be loaded by default. And let's cycle through all those again, and that's it. So that's what our program does in a nutshell. That's what the assembly does. And so we're going to stop here today, and I think the next chapter we're going to deal with some input device basics, which I might skip because I'm really more interested in kind of just continuing with the graphical stuff. We might revisit the input stuff when we need it, but I think we'll go ahead and go on to chapters 4 and 5 next time. So thanks for watching. Hit like if you like the video, and we'll talk to you later.